Hello everyone and welcome back once again. In this video, we'll be focusing on artificial intelligence, machine learning, and deep learning. It's crucial to grasp these ideas initially because they serve as the foundational pillars for understanding generative AI. So let's go through them one at a time. First off, what exactly is artificial intelligence? Let's clarify it. Humans happen to be the most intelligent species that has ever walked the earth. We excel across all domains, be it science, art, or sports. The human brain is arguably the most sophisticated entity on our planet. That is what we call genuine intelligence. When we attempt to mimic this intelligence in a machine, that is, to create a machine that is as smart and as capable as a human, that's known as artificial intelligence, or AI. Thus, AI refers to developing machines that can carry out tasks that normally demand human intelligence. For instance, you could build AI systems to diagnose illnesses using X-ray images, forecast real estate values, or even detect fraudulent credit card activities. All of these are tasks humans handle using their natural intelligence, yet machines can also accomplish them. And that, in essence, is AI, integrating human-like intelligence into machines. A question that might arise here is, how do machines manage to do that? How can they rival human intelligence? This is where the concept of machine learning appears. So, what is machine learning? As the name suggests, it's about teaching machines how to learn. We aim to train them so they can make predictions, make decisions all by learning autonomously, with no specific, detailed programming from human developers. We coach a machine, it processes the information independently, and then it can perform forecasts or whatever else is required without us constantly guiding it. That is what machine learning entails. After learning this, you might wonder, okay, how do we actually make machines learn? Think about it, and I will guide you step by step. We'll advance one level at a time. I'll explain everything in a very straightforward, engaging manner so that your core principles are absolutely clear. So if you consider it, how do we humans learn something? For example, think of a young child learning about apples. They see many fruits around them, bananas, oranges, apples. Over time, they figure out that anything round and red is likely an apple. From that point on, if you place 10 different fruits in front of them, they can easily recognize which one is an apple. They recall the fruit's traits, having seen it and memorized it. And that's the method by which all of us learn. We observe examples, register specific features that make an object unique, so that when it appears again, we know whether it's an apple or not. This is basically the same method machines use to learn, except they require a vast amount of training data. We supply a machine learning model with millions of apple images, various shapes, sizes, shades, and types, so that when you finally show it two different fruits, the model is able to identify, based on its training, which is an apple and which isn't, right? So the core machine learning principle aligns with human learning. But there are a few key differences. Firstly, a huge volume of training data is necessary. As mentioned, humans are naturally very insightful. We can identify a cat by sight, regardless of whether it's golden, black, or white, covered in mud, young, or fully grown. We do this quite naturally. However, to instill the same competence in machines, to make them as sharp as us in these tasks, we must provide them with enormous amounts of data. We might need to show them millions of cat images of varying colors, types, and sizes in order to reach high levels of accuracy. Additionally, we need significant computational resources. Since we're dealing with massive datasets with extensive calculations and multiple optimizations, we need powerful hardware. Historically, machine learning models had certain constraints largely because of limited computational capabilities. However, with the widespread availability of GPUs at lower costs, computing power has surged tremendously, leading to highly advanced modern models. Finally, there must be a robust algorithm at the core, one that processes all this information, learns from the training data, uncovers patterns, and produces forecasts or performs tasks on your behalf. The overall idea is you provide the machine with vast amounts of data, allow it to analyze and detect patterns, characteristics, and clusters, and then expect it to carry out the specified tasks on its own, with little human direction. That's how we enable machines to learn. That's how they develop artificial intelligence. Now that we've covered what AI is and what machine learning is, let's turn our attention to another variation within machine learning, deep learning. As mentioned, deep learning is just a specific branch of machine learning, but its core mechanism is based on the concept of neurons, similar to how we have neurons in our bodies. Think about how the human body transmits information. We have a network of neurons interconnected all over, and for instance, when you see something through your eyes, these neurons carry signals from one to the next, ultimately reaching your brain, which processes the image and tells you it's an apple or a cat. What's essential to note here is that these neurons exist in multiple layers, each connected to the next, passing along signals for analysis. And this layered process, one layer refining the information before handing it over to the next, is a key factor behind human intelligence. Engineers took inspiration from this and thought, well, this is what gives humans their brilliance. How can we replicate it? What if we apply the same principle to machine learning? And that's how neural networks were devised. Here too, as you can see, multiple layers of computations are set up. Each layer accepts the output from the prior layer, examines it, learns from it, improves it, then forwards it to the next layer. That subsequent layer does the same, studying, processing, and learning before handing it on and so forth. Hence, having such a multi-layer neural network significantly boosts accuracy, especially for complex tasks like generating text, because each layer refines the data from the previous layer. This enhances the machine's ability to comprehend, compute, and predict, ultimately achieving far better results. In fact, this neural network technology underlies generative tools such as ChatGPT. We'll explore this more extensively in the upcoming modules. The key takeaway, however, is that for intricate challenges like text or image creation, deep learning networks outperform older machine learning methods. This advantage comes from their multi-layered architecture. You've probably deduced by now that this is also quite complex. You need significant computational firepower to shuffle and process data through so many layers. And you're completely right. Neural networks demand ample computational resources, and in the past that did limit their use and the extent to which they could be refined. But as mentioned earlier, with modern computational advances such as GPUs, training and using neural networks has become much more cost-effective, thus accelerating their use, particularly in generative AI. So let's define deep learning. It's a specialized subset of machine learning that analyzes data through neural networks, leading to remarkably accurate solutions for challenging problems. You don't need to commit every detail to memory, just remember these three key points. First, deep learning is part of machine learning. Second, it relies on neural networks. And third, it delivers considerably more accurate and superior outcomes for complex tasks. So we've covered AI, machine learning, and deep learning. Let's place them side by side for a clearer picture. Artificial intelligence refers to constructing machines that exhibit the same intelligence traits that humans naturally possess. Machine learning is essentially the driving force behind AI, enabling machines to learn and evolve as time goes by. Deep learning is a subcategory of machine learning that applies neural networks to tackle complicated issues. These are the three fundamental concepts we need to understand before progressing further into generative AI in more detail. Now that we've sorted this out, let's move on to the next video for a deeper exploration of generative AI. I'll catch you there. Thank you.